Good morning, everyone. Myself is Dr. Ajit Kumar, and I'm faculty in the Department of EC at Presidency University. We will continue our lecture. Today, I think it is seventh lecture. In this lecture, we'll study. There was a concept which was push and pop. Okay, we'll continue that push and pop instruction after one topic which is called addressing mode of 8051 microcontroller. Fine. Let us try to understand the addressing mode and then we'll start our push pop instruction. Okay. So here this push pop instruction will be continued after this topic that is called addressing mode. Fine. So here addressing mode. So the topic is addressing modes. Okay. Now the definition of this addressing mode. The definition of addressing mode is the way. Now this definition is applicable for all the microprocessor, all the microcontroller. Okay, so this is a broad definition. So the what is addressing mode? The way the operands operands okay, are specified in the instruction in the instruction. This is the definition. Now, you know that every instruction has basically two parts. Okay, though there are other parts. Okay, so if you see the format of instruction in ALP, assembly language program, then it is something like this. We have first level, though level is not associated with every instructions. Okay, then we have opcode, then we have operand, okay, and then we have comments. Comment is also optional. Fine. Now this level is the actually this level is the name of address. Okay, name of the address of the instruction I will explain about this one later on. At this moment, you are supposed to just know this one. This opcode. This opcode is operation code. Is operation code. Actually, that is the this opcode is the abbreviation of this operation code. Okay, so basically it shows that what operation is to be performed. For example, move, add, okay, and so on. Then this operand, okay, this operand is the data, is the data on which operation has to be performed, on which operation is performed. Now see the definition here. Okay, what is the definition is the way the operands are specified. See, the way the operands are specified in the instruction. Okay, so that's why I told you about this format of any instruction because here this is the operand. Okay, this is the operand that is coming here. Just before I explain this definition, no, it will become easy to understand from some examples. Okay, so let us try to understand this from example. Now I know that you people are not aware of the instructions of 8051, but still I hope you understand two instructions which are move. Okay, move and add. Based on these two, I am going to explain. the concept of this antecedent. So before that, let me try to explain what is this move. So this move actually copy copy the data from source source to destination. Okay. For example, if I write here something like this, move A, comma R naught. So this R naught is source. Okay, source is always written in the right state, and this is destination. So here we have two operands. One is source operand. Okay, this is source operand, and this is called destination operand. Fine. So the data, whatever is stored in the R0 register, will get copied into R0. Okay. Another one, another example. Suppose I have written here this way: move A, comma as 45H. Okay. So this 45. Now this A is our destination. This is our source, and we know A register is 8-bit register. Okay. It is 8-bit register. So one, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7, 8, 8-bit data. So after executing this instruction, this 45H will get stored in the register A. Now what is this 45? This is in hexadecimal. In the binary form, 4 is 0, 1, 0, 0, 5 is 0, 1, 0, 1. Now this is 8-bit data. This 8-bit data will be stored in this register A. Okay, so it is something like this: 0, 1, 0, 0, 0, 1, 0, 1. Okay, so this is after this instruction. Okay, after execution. Right. Just one. Okay, so here we have, just try to understand this move instruction, and then what this add instruction is used to add. Okay, source operand with destination operand. Okay, for example, add A, comma R naught. This is source operand, this is destination operand. So the meaning of this instruction, add A, comma R naught, is that it is going to add the content of register A with the register content R naught, and the result will be stored in A. So to add the source operand to the destination operand, and store the sum in destination. Destination. Okay. Now destination is D. So your sum is stored in the A register. Okay. And always remember that in 8051, the destination is always register A. Okay. Four, four. All arithmetic all arithmetic and logical instructions. We'll study more example on this one later on. Okay, so at this moment, you try to understand that whenever you are going to write any add or difference instruction, okay, like SUBB, so okay, there also destination will be A. Okay, this source could be any register, okay, or it could be any memory location, or it could be immediate value. Okay, similarly here also, this A will be always fixed in the destination. The source could be any register, okay, or it could be uh, memory address, or it could be immediate value. Okay, so we'll see this one later on. So this, okay, now to understand the concept of addressing. Okay, so let us try to understand first of all this one concept of addressing. See, suppose, okay, so let's say suppose I want to add two numbers. Okay, I want to add 45H with let's say 25H. These two hexadecimal number I want to add. Okay, now you know that this addition can be done by the processor. Okay, because the processor is a computational device which can compute or you can do any operation on the data. Okay, so whatever this addition, subtraction, multiplication, division has to be done, it is going to be performed by the processor. So now processor is not going to get this data in air. Okay, this 45, the data here which is supposed to be added is 45, 4 or 5 bytes and 2 5 bytes. These are supposed to be stored at some place. Okay, let's say any, okay, so this is your, suppose this is your processor chip, microprocessor chip. Okay, so this is your microprocessor, okay, chip, and let's say here we have another chip which is our memory chip. So inside the processor, all the registers are actually there. Okay, all the registers A, R0, R1, R2. Okay, all these are actually inside the processor chip. Okay, and the memory chip we have discussed. Okay, that we have different locations, and in each location, 8-bit data can be stored. Okay, and I said that each location have some addresses here. Okay, so, for example, let us say that this is the address. Let us try to take the same address that we have studied. 00H, okay, then 01H, 02H, 03H, 04H, 05H, 06H. Okay. Now, what is our target? Our target is to add this 45H with 25H. Okay. So we know that this number 45H when added with 25H we give you something like this 5 plus 5 is 10, but 10 in hexadecimal is written as 8. 4 plus 2 is 6, so 6AH is the answer. Okay, this you can verify in the binary addition also. You can write the binary form for 4 is 0 1 0 0 and 5 is 0 1 0 1. Similarly here 2 is 0 0 1 0 and then sorry 5 is 0 1 0 1 and then the binary. So 1 plus 1 is 0. Remember about carry 1. Then 1 plus 1 is 0. Carry 1. Okay. And then 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 1 is 1. And this. So you know this 0 double 1 0 is 6. And this 1 0 1 0 is 2. Fine. This is the addition that has to be done. Okay. Now who is going to do this addition? That we have already seen. Okay, that there are many ways that in which for this addition to be performed, no, we have to write the program. Okay. We have we have to write assembly language program. Okay, for this addition. Otherwise, the microprocessor will not be able to do this addition. Okay, we have to write the instruction set of instructions which is called program. So that set of instructions will be executed by the microprocessor, and finally, after execution of those instructions, the processor is going to give you this 6A as sum. Okay, so now in this case, we can, as I said, that first of all we need to store these values 4, 5x, 2, 5x, some at some locations or some or storage variables. Okay, so there are many ways in which you can do this one. See, first way is the first way is this. What is that number? 4, 5h. So 4, 5h has to be added with 2, 5h. So what I'll do, I will store this 4, 5 which let's say in the register A. This I will store in the register R0. How I can store? Using move instruction. So I can move, and as I said, there are two operands. This is source, this is destination. So this is source, this is destination. This one. So source will be written as has 4, 5x. Now this has, so this, I mean, this actually called pound sign. Okay, it is called pound sign, and this pound sign is always placed just before the number so that it can show that this 4, 5h is a constant number. You have to write h here, otherwise it will be treated as decimal. So this 4, 5 is constant number. That is, see, why I'm placing this hash sign, because this is a constant number. If you see this number 0, 1, 0, 2, 0, 3, there are also some numbers. Okay, if you don't place here as, then it will be treated as this memory address. Okay, so to distinguish the constant values on this memory address, this constant is actually placed just before the constant value. So where is it to be stored? In the register A, so A is destination. Okay, so by this instruction, the value of A is 4, 5h. Okay, so I'm not right here. Okay, this side I'll write the second method by which we can do this addition. Okay, so let us continue this first one. So here the first number has been stored in the register A, then this another register has to be stored in the R0 register, so I write the same thing. Move. Now this R0 is source and this, sorry, destination, so I write destination first, and then source is has 25h, 25h. Okay. So by writing this instruction, our R0 register will contain 25h, and by writing this instruction, the value of A, that is register A, will contain 4, 5h. As I explained just now in the new instruction. And then I will write here something called add. Add, as I said, that A is always the destination in the case of arithmetic instruction. Arithmetic is addition, subtraction, multiplication, division. And it, A is always placed in the destination for arithmetic as well as logical, like or exam, okay, and those kind of logical instruction. In those cases also A is always destination. Add A, comma R naught. What is the meaning of this one? A is equals to A plus R naught. So what is going to happen? The value of A will be, this value of A is 25h, so 45h, and with R naught is 25h. Okay, and what is the sum? 6A. Okay, so here this A was for 5h. Now the value of A is 6AH. Okay, so here this A will be replaced, whatever was the value of A before executing add, okay, that will be replaced by this new value. Okay, so this is the sum, and this sum is stored in the register A. This is actually one way in which we can write the ALP to that addition of these two numbers. Similarly, there is another way. Okay, let's say this I will store it in the register A. This I will not store. I will not store anywhere. Okay. Here to store this value of A, again you have to write move A, comma hash 4, 5h. Then I write here add A, comma. Now I directly write the second of number, that is 2, 5h here. Okay, so what is the meaning of this instruction? the meaning of this instruction is this is destination, this is source. So destination, okay, it is always destination is equals to destination plus source. So it is A equals to A plus 25H. So in this case, A value is 45H will be added with 25H and the sum will be stored in A, that is 6AH. Okay, this is the second method. Okay. Now recall that this A is the part of CPU or you can processor. This is also these two registers was the part of CPU. Okay. So what we have done is in the first and second method, okay, in the first and second method, okay, we have stored one, I mean, either both operand in this registers or one of the operand in the register A and another as immediate value. Okay, this is called immediate value. I'll tell you later on. Fine. So this was the second method. Then we have many more methods by which I can perform this addition. Okay, let us say the third way. So third way is now this 4 5H is supposed to be added with 2 5H. Okay. So this number I'm going to store in the register A. This number I'm going to store, okay, store in memory chip address. Memory chip. Okay. Now let's say in address 04H. Okay. So here what is going to happen? Now see here. This is our processor. Okay. Inside this processor, okay, inside this processor, we have register A, in which I'm going to store this value of 45H, and this is our memory chip, in which we have different locations. Okay, in which location, for example, this is 00H address 01, 02, 03, 04H. So what I'm saying is this 45 are stored in the register A, which is a part of the processor. This 25H I store in this address. Okay, address 04H. So where is 04H? Here. So in this address 04H, I'm going to store this 25H. Okay, here, 25H. Okay. So here I'm going to store this value. That is here in this location. This value is stored, and another number is in the register A. Fine. So to store this 45H into register A, I'll write this instruction move A comma has 45H. Then another number has to be stored in the address 04. Okay, so I'll write again move. Okay, again recall we have two things here, that is destination, source. So this address 04 will be destination and this is source. Okay, so I'll write source as 25H and then I write here the address 04H. See this as sign. If you see here, we have two things. Both are the numerical numbers. Okay, both source and destinations are numerical numbers. However, this is a constant value. Okay, this is a constant value. Why? Because we have placed here as sign. This 04 is memory address. Memory address. Why? Because there is no pound sign. Okay, there is no pound sign. Right? So this is how this memory address and constant values distinguished using pound sign. Now both values have been stored here. So the final instruction that I'm going to write is add. Again, two things are there. This is destination, this is source. I told you that destination is always going to be a register. This is 04H address. Now what is the meaning of this one? It is saying add what is the this one concept of this? So D is equals to D plus source. Destination plus destination plus source. Here the destination is A, so A is equals to A plus what is source? 04. What is the meaning of that one? The data stored in address 04. Okay, this is the source. So what is the meaning of this one? The meaning of this instruction is to add the content of a with the content of memory address 04H. So I already know what is the content of the memory address 04H. This is 25H. There is a content of register 45H. Okay, these two values will be added and the result will be placed in sum. Okay, the sum will be placed back in a register. Okay, this is how it is done. Fine. So this is the third way. Okay, now like this, now we have another method also, which is called. So let us try to understand. I mean, let us just come back to our discussion, the definition of addressing mode. Okay, so see here. Let us observe the instruction A in all the three cases. Okay, just I will highlight it. See, here we have taken this add instruction. Here we have taken this add instruction. Here we have taken another instruction, add instruction. See, there is another add instruction. Now see what is the difference in all this app. Okay. In here, now recall the definition of add instruction. If you recall the definition of add instruction, I said the way the way the operands operands are specified in the instruction. This was the definition. See in the first instruction, okay, we have two operands. Okay, the data to be added are actually in the register A and B. So here both operands, okay, are in register. Okay, see this one. Here one operand is in register and another operand another operand is directly directly or immediately immediately specified specified in the instruction in the instruction. And for this instruction, one of the operand, okay, one operand is in register A and another operand is in memory address. But in all the three cases, we are able to do the addition of the both operands. Okay, this, I mean, the only difference is that how we are actually specifying the addresses or how we are taking the different operands. Either we are storing the both operands in the registers or one operand in the register, another one as input value, or we are storing one operand in the register, another one in the memory address. Okay. So this is actually your definition of the addressing mode. So in general, in our microcontroller 8051, okay, in microcontroller 8051, we have six, six, total five addressing mode. Okay, we have total five addressing modes in our 8051 microcontroller that we study one by one. It's very easy. Not to worry. The first addressing mode is immediate addressing mode. The second one is register addressing mode. The third one is direct addressing mode. The fourth one is register indirect addressing mode. And we have indexed addressing mode. So let us try to understand. Total there are five addressing modes. Okay, so we'll understand one by one here. Okay, so types of addressing modes. Types of addressing modes. Okay, in 8051. Okay, so we have here, let's say I'm showing you by three. It is, I will start from register addressing mode. Register addressing mode. Then we go for immediate addressing mode. Immediate addressing mode. Then we go for register, oh sorry, direct addressing mode. Direct addressing mode. Then we will go for register indirect addressing mode. Register indirect addressing mode. Okay. And finally we'll study about indexed addressing mode. So see here, in the register addressing mode, okay, in register addressing mode, both 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 operands, both operands means source and destination. Okay, both operands are specified, are actually you can say both operands are registers. Okay, example, move A, comma R naught. So you can see this is the register, this is the register. Okay, the source is also registered, destination is also registered. Another example, move R2, comma A. Again, both operands are registers. Okay. Another example, add A, comma R naught. Okay. So all these are the examples of register addressing mode in which both the operands are registers. Okay, quite simple. As the name suggests, register addressing mode means both the operands will be registered. But in this case, remember one exception is there. Okay, that exception is you if you write here like move R naught comma R1, then this is wrong. If you write like move R2 comma R3, then it is wrong. In general, you cannot write Rn suffix comma Rn suffix. Okay, that is you can't move. Okay, you can't move data between Rn register and Rn register directly. Now, I mean, the people are asking that why it is there. Okay, what is the logic is, if you remember, this is our RAM, and we have seen that in RAM, we starting address is 00. Okay, when they will have 01, then they have address 02, and so on. You also remember that this R is actually designated by R0 register. This is designated by R1. This is designated by R2. Now, in all the microcontroller, all the microprocessor, there is a rule which says that you can't move, you can't move the data from one memory location to another memory location. One memory location to another location. This is the general rule that is followed. Okay, from one memory address to another memory address. Directly you can't remember this one. That is, if you are going to write like this, move 01H, 02H. Okay, suppose that here in 0 at 01 there is 4, 5 stored here. Okay, this value you want to store in this address 02. Okay, so that is not possible. Okay, because this is also memory address. Okay, this is also memory address and this is also memory address. Both cannot be the memory address. You cannot move the data from one memory address to another memory address, and that is why. If you remember, this memory address is pointed by R1, this memory address is designated by R2, so this is also wrong. Move the 01 is R1, comma 02 is R2. So this is also wrong because directly, indirectly they are showing the memory address. Okay, so this is also wrong. So this rule is very important that you have to remember. Okay. So this register addressing mode is that addressing mode in which both operands are registered. Okay. Then let us come back to another addressing mode which is called immediate addressing mode. Okay. Immediate addressing mode is quite simple. Here it says that one, not one, actually it is always source. Okay. Source, source operand is okay, is directly, I should not use the directly because here direct code is there, is immediately, immediately specified or mentioned, specified or mentioned in the instruction. For example, try to understand. This is move instruction, this is move mnemonics, mnemonics. We have two things. Okay, that is source, destination, source, comma, sorry, destination, comma, source. What I'm saying is, this is source, this is source, this is source. The source is always directly given in the instruction, or you can say immediately given in the instruction. No need to store this in any other register or any memory location. Okay, let us suppose that these are the constant values. Okay, so the constant value is always given in the source. This destination could be anything. Here it could be A register, here it could be R0 register, here it could be the memory address. Let's say 50H. Okay. Another example, suppose that you are writing add instruction. So in add also, there are two things. This is source, this is destination. So the data is directly given in the source here, not stored somewhere. Okay, so here destination. Okay, so it's very something like this. Here there are two operands. Okay, so this operand, this is source, this is destination. So I am saying that source is always given as constant value. Okay, here that constant value will be written. It could be any constant value, but the destination has to be always a register. Okay, so this constant value is always given in the source in the immediate addressing mode. Okay, and since this is immediately, immediately means quickly available in the instruction, that is why it is called immediate addressing mode. Okay. So this is the second addressing mode. Then we have the third addressing mode. Okay. Now the next one is direct addressing mode. See, in the direct addressing mode, in the direct addressing mode, either either source or destination is memory address. Memory address. Okay. So either source or destination is memory address. For example, if here two operands are there. Let's take another example. Add two operands. Okay, this is destination, this is source, this is destination. What I'm saying is either source or memory address, sorry, either source or destination will be our memory address. Okay, so here the memory address, let's say 04H is there. Now this 04H is not preceded by pound sign, so it is constant value. Okay, this is constant value. So and here suppose that I'm writing here register A. Okay, so here if what I said either source or destination is memory address. Now this is a memory address. Okay, this is a memory address. Okay, so this is direct addressing mode. Okay, so this is direct addressing. Okay, similarly in the add also, if you are writing a add a comma, because in the addition, subtraction, multiplication, division, or you can say XOR, XNOR, all those arithmetic and logical operation, one of the sorry destination has to be definitely a register. So in this case, the source will be your address. Okay, this source will be the address. So let us assume that any address something like 00. Okay. So this source is address. So this is also a direct address. We now come back to this one register addressing, register indirect addressing mode. See here, how many we have done? Three, I think. So this is fourth one, register indirect addressing mode. The register indirect addressing mode. Uh, what is there is the address, okay, the memory address. The memory address is pointed pointed by the register. Pointed by the register. Which registers? Okay, always R0 and R1 register. Okay, that is why it is called see register indirect. Because see in the direct, if you see in the direct addressing mode, we have seen that address was given. Okay, and what is given is register indirect. So this register will actually okay pointing to this address. Okay, so and which registers are used here? R0 and R1 are used. Okay, so I mean how this shown? See, I'll show you with something like this. Let's say this is our memory address, the memory chip, and let's say we have the addresses 00H, 01H, 02H, 03H, 04H. Okay, so this is our memory chip, and let's say that here we have microprocessor. Okay, so in the microprocessor, let's say there is a register R0, R1, and so on. Okay. Now, uh, suppose that in this address 04H, okay, in this location, whose address is 04, okay, so in this one, okay, let's say I want to store constant value 25H, okay, so you already know using direct addressing mode, we can do it like this. Move. Here we have destination, here we have source. So you know that this 25 is source and this is destination. 04 is the destination. So I'll write here 04h and here I'll write this constant value 25h. This is method 1. Okay, this is method 1 in which we are using direct addressing mode. Okay, direct addressing mode. Because what I said, any one of the options should be memory address. Method 2 is method 2 is we are going to use this register indirect. Now what I will do is, what is this address 04? This address 04 I am going to store in the register R0, okay, or R1. Only these two registers can be used. And then, so I'll write something like this. Move, okay, this 04 has to be moved in R0. So this R0 is destination, comma, because this 04 is now a constant value which will be treated as constant value. Okay, okay, so I'll write here has 04. Okay. What is the meaning? The meaning of this instruction is the meaning of this instruction is R0 is 04. Now, what is our target? To move this 25 in this memory address 04. Now, this memory address is pointed by R0. So, this R0 is memory pointer. Okay, so this R0 is memory pointer. Then I will write something like this, which is very important here. Move where I'm supposed to move in the address 04. Address 04 is pointed by R0. So I'll write here at the rate R0. This is destination. Then I write here constant value 25h. What's the meaning? It is something that move, okay, 25h in the memory address, in the memory address. What is that memory address? 04h. And this memory address is, okay, which is pointed by, which is pointed, which is pointed by R0. Let's see. This 04 actually got stored in R0. So that's why I'm saying that R0 is acting as memory pointer. Okay. So this, when you are placing at the rate, okay, when you are placing at the rate, okay, before R0 or at the rate R1, then this is actually memory pointer. And it is actually and this is called register indirect. Register indirect attachment. Okay. Why this is called register indirect? Because this is actually pointing to, okay, if I would have written here 04, okay, has 25h and here move. Now this instruction move 04h has 25h is same as this one. Okay, both instructions are same. But this address 04 is not being pointed by the R0. Okay, so that is why it is this second one is actually called direct addressing mode. So this direct addressing mode is being now indirectly pointed by the register. So it is called register indirect addressing mode. Okay, this is actually the difference between register indirect addressing mode and direct addressing mode. And where it is useful, it is very useful. Okay, this register indirect addressing mode is useful to reduce the size of the program. To reduce the size of ALP. We'll see with some example. Okay, and it is also used when we'll be using loop kind of looping or nested loop type of program. Okay, so in that case, I'll show you with example that how this is very useful. Okay, the last one is called index addressing. Okay, now see where this index addressing more concept comes. Okay, inside this microcontroller 8051, okay, we have various registers already. We have know that all the registers are the part of this 8051. So inside this 8051 chip, we have this register also, and then we have on chip RAM. Okay, this is on chip 128 byte of RAM. Okay, then we also have on chip ROM. On chip ROM. So whatever I explained till now, the direct addressing mode or whichever addresses I was taking was actually for this RAM. Okay, all the addresses I have used for this RAM. Now we have this on chip ROM, okay, which is also called code space. Okay, or it is also called RAM. See, here we store our program. Okay, the program that you write, okay, that is ALP assembly language program which you write is actually stored in this ROM. Stored in this, stored in on chip ROM. Fine. So in the index, I mean, whenever we are moving the data between RAM or these registers, okay, then we have seen we were using move instruction. Okay. However, if you want to move the data, okay, from registers to the on-chip memory, okay, then we use the instruction move C. C stands for code. Okay, C stands for code. Okay, so here the instruction was move when RAM address RAM address is used. Okay, and here move C is used. Okay, move C is used when this on-chip ROM, you can say ROM address is used just to distinguish. Okay, and what is the syntax for this instruction is here the syntax is something like this. Now, since it is wrong, so the data will always go from okay, it is we are going to do only one thing, read operation. So read operation is to to read data from memory. Okay. So you are always going to so this arrow will also change here. Okay. The data will always be read from this on-chip ROM to register A. There is fixed syntax for this one. So I write here move C. You know there are two operands here, destination and this is source. So this time the destination is always register A. However, okay, however, this source is again actually being pointed. Okay, here the source is uh, this ROM address pointed by some of A, and there is another register which is called DPTR. Okay, so DPTR is actually called data pointer register. Data pointer register. This is actually 16-bit register. This is 16-bit register. And this is 8-bit register. So this is a ROM address pointed by sum of A and B. So it is written. because it is pointed, so I write here at the rate, and then I write here A plus DPTR. This is actually source is always the RAM address, which is actually this. Now the RAM address is actually the sum of A and DPTR. Okay, so here let's suppose let's this is your number. You can say 8051, 8051 IC, and here this is your ROM. This is your ROM. I'm not talking about the RAM, that is not being discussed here. Now this ROM, if you remember, in 8051 is actually 4K byte, 4K byte, and it is also possible that a 64 kilobyte, yes, 64 kilobytes of ROM can be also used here. Now in that case, no, the address is because 64 kilobyte is actually means there will be address here. The address size is not 8 bit, it is actually 16 bit. So 16 bit means it could be something like this 0000H. Okay. Now this 00H is a 16 bit address because if this 0 is designated by 40, this 0 is designated by 40, and so on. Okay. 1, 2, 3, 4, and 1, 2, 3, 4. So it is 16 bit address in the for this on chip ROM. Chip ROM. Okay, so what is happening? Let us take any intermediate address. Okay, so let's say this is 000, then let's say this is 001, okay, then 002, okay, and so on. Now, suppose that in 002H there is something, let's say 45H store. Okay, so what is happening is, and I wish that this 45H should be read and brought inside the register A. Okay, now see here, what I will do is, I will see this. You can do it in two ways. Either move this base on the base address in the DPTR. So I'll write here something like this. Move DPTR. Now DPTR is a 16-bit register, so the 16-bit data can be copied into this 16-bit. Because it is being it is treated as constant value here. Okay. So and then I will write. See where is this located in 002. So this is actually at the offset of 2. So I write here more a comma has okay 0 to h. Fine. Then I write something like this. Move c a comma at the rate a plus dptr. Now see here. What is this a plus dptr? A is 0 to okay. You can say 2 and this dptr is 0000. So their sum will be 0002h. Okay, and now this 002h address is pointed by the a plus dptr. So the data from and what is the data there? The data in this memory address is okay 45h. This data 45h will go in the register A. Okay, so this is called index data symbol in which this C is added with move okay, to distinguish that on-chip memory is being used currently. Okay, so we have discussed all the addressing mode of 8051. In the next class, we'll discuss about the push and pop instruction. Okay, so thank you everyone.